Okay, let's say that continuing with rational expressions. Now we looked into addition of rational expressions as well as subtraction. Now let's say if we cross over to multiplication. And let's say that if we're looking at with rational expressions, and we'll say we have 3x squared, y cubed, over 4xy, and then we have times, so we have 5x squared, y to the ninth, and say we have all over, in this case we'll say that we have over 7, y to the fifth. Okay, now there are varieties of approaches that you can take, and some of you might go with cross multiplication, but I tell you what, we'll just multiply directly the numerators and denominators. Okay, so you have 3 times 5 is 15. For what we have at the top in x, we have x squared times x squared. So this will go to x to the fourth. And for what we have in y, y to the third times y to the ninth. So we have y to the 12th. Now for what we have in the denominator, okay, so you have 4 times 7 is going to be 28. We have x, y times y to the fifth, so this will be at y to the sixth. And for taking what we have and reducing this rational expression, now we have 15 over 28. That part is already in simplest form. And for x to the fourth over x, we're going to have x cubed. And for y to the 12th over y to the sixth, okay, so that is going to be at y to the sixth. Now let's say that if we take the very same ratios, and let's say that we have, instead of multiplying, okay, we'll look at division. And let's say that for this one, okay, so we got so you have 3x squared, y cubed, over 4xy. Now if I'm dividing by a fraction, and I'll rewrite in terms of multiplication, I'm going to have division by a fraction will be the same as multiplying by the fraction's reciprocal. So you have times 7y to the fifth over 5x squared, y to the ninth. And if I multiply together, so I got 3 times 7 is 21. And I have x squared, y to the third times y to the fifth. So this is going to be y to the eighth. As for what we have for 4 times 5, okay, so that's going to be 20. X times x squared is going to be x to the third. Y times y to the ninth, okay, so that's going to be y to the 10th. And it turns out that the higher degrees in x and y will be in the denominator. So just taking what we have now. So we have 21 twentieths. And we have x cubed and x squared, so you have a 1 degree difference. Higher degree, again, you have in the denominator by 1 degree, and for y to the 8th into y to the 10th. So that's going to be a y squared. And so this is what we have in this particular result of the quotient. Now, and let's say that if we have not just single term or single variable expressions, okay, let's say that if we have binomials and trinomials in the mix, and let's say that if we have something such as 3x plus 6y and we'll say that we have all over. So you have x squared y to the fourth, z to the third, and we'll say that we have times the quantity of 2x plus 7y and I'll say here you can have multiplying. Okay, so I'll say that I have 20 x to the fifth y and z squared, and I'll say that I have times the quantity, and we'll say we have 8x plus 28y, and we'll say that we have all over 9x plus 18y. All right, so what we can do is that in terms of just lowering in terms of just the degrees in x, y, and z to let's say that for what we have at the moment. Okay, so we have the binomial expressions. If we go ahead and reduce where possible. Okay, so if I rewrite what I have in factored form, so we have for 3x plus 6y. Now we're going to have for the greatest common factor. So we have 3 times the quantity of x plus 2y. And we have all over x squared, y to the fourth, z to the third, and 2x plus 7y. So that is already in simplest form. And we have in the numerator, so you got 20 x to the fifth times y times z squared. And for 8x plus 28y, now the greatest common factor is going to be at 4. And 4 into 8x plus 28y, so that's going to be 2x plus 7y. And we have in the denominator, okay, so we have for 9x plus 18y. Okay, now the greatest common factor is going to be at 9. And we have x plus 2y quantity. And if you notice, okay, we have, we can get the x plus 2y to go out. And likewise with 2x plus 7y, we can get those to vanish as well. And if we take what we have in the mix, okay, so you got 20 times 4 is 80 times 3, so we have 240. X to the fifth, y, z squared, and we have over 9, x squared, y to the fourth, z to the third, and for 240 over 9, greatest common factor is going to be at 3. So we have 3's to cancel. For x to the fifth over x squared, okay, this will become x cubed. Y over y to the fourth is at the bottom, and that is 3 degrees higher. And for z squared over z to the third, okay, we have 1 degree higher in the denominator. So we have for the final form on this one, so we have 80x cubed all over 3 times y to the third times z. And let's say that for what we have concerning rational expressions, and I'll come up with one here. And let's say that if we have 4x plus 7y and we'll say we have over 3 x squared y to the 4th z cubed, and I have divided by eight x plus 14y. I say that I have over 9x y to the 9th z to the 7th. Okay, and if I take what I have here for this problem, if I re-express in terms of multiplication, so I have 4x plus 7y over 3x squared y to the 4th z cubed, and multiplying by the reciprocal, so you have times 9x y to the 9th z to the 7th, and we have all over 8x plus 14y and again, if I reduce what I have for the binomials, okay, so I already have 4x plus 7y over 3x squared y to the 4th z to the 3rd, and we have in the denominator, okay, now the greatest common factor we're going to have at 2. We have times the quantity of 4x plus 7y and with 4x plus 7y, so we're going to have those expressions to cancel. So we have at this stage, okay, so we've got 9x y to the 9th z to the 7th, 2 times 3 is 6 x squared y to the 4th z to the 3rd, and 9/6. We can go ahead and reduce this part. Greatest common factor is going to be 3. 9/6 is 3 halves. X over x squared leaves us with 1 degree at the bottom. Y to the 9th over y to the 4th leaves us with y to the 5th at the top. And for z to the 7th over z cubed, we're left with z to the 4th in the numerator. So for what we have here is going to end up as the final answer.